Roger, I did my doctorate work in neurophysiology, and the assumption at the time was that if we're ever going to explain consciousness, it has to be at the level of the neuronal activities. That's where information seemed to be flowing, it was spiking, maybe there was some generalized electrical activity in the brain that modulated it, but one way or another, that's what it had to be at the synapse, etc. You've asked us to consider that real activity is happening at the quantum level. And I have to ask, why do we need that? Because quantum effects are everywhere. Why is it so special in the brain to understand how consciousness works?
Well, the idea that I had, because of my views about understanding being something which is not a computational activity, I needed something which involved that part of physics which, in my view, had a hope of being non-computational. And the only part of physics is that I could think of then and can still only think of now is where you have a quantum system which becomes a classical system. See, this is one of the big puzzles of quantum mechanics. How is it that you have these rules like, Schrodinger's cat being dead and alive at the same time, which are what you get from quantum mechanics, but you don't see them at the classical level.
Yes.
So there's something missing in the gap between quantum and classical. Now, the question is my argument would be that the physics that is missing about how the quantum world becomes the classical world is something which I think is the only place where you would have non-computational activity. Mm-hmm. So if we think non-computationally, we must be making use of whatever that physics is that goes from the quantum to the classical world. Now, that's a big, tall order, because it means that in the brain, we have to sustain a quantum system to such a degree that whatever this new physics is, it comes in and becomes relevant. Whereas usually what happens is the quantum system becomes entangled with the world, the environment, and you lose all what people call environmental decoherence. Mm-hmm. And when that happens, you lose the information that would be relevant in the new physics. So you've got to keep your quantum system going for that degree so that the new physics actually comes in usefully. Now, I wrote my book, The Emperor's New Mind, in a way trying to explore this, hoping that by the time I got to the end of the book, I would know what it was. But I learned various things when I was writing my book about the brain and what people thought about it, but I didn't get to, I simply didn't get a good reason for what. So the thing is, neurons, clearly, at least what I learned about neurons, clearly the firing of a neuron will disturb the environment in the brain, and there's no chance of keeping this coherence. So it needed something more. So the book was a failure in that particular respect, except that Stuart Hameroff read my book and he wrote to me and said, I think you may not know about these things called microtubules. And I said, well, actually, I don't know about them. In my ignorance, I'd never heard of them. I thought, is this another nut? I get letters from various people that I have to discard like this, but then, here are pictures of them. Gosh, they must be real. And so I said, this sounds extremely interesting. There's a much better chance. You have these little tubes, they're very symmetrical structures, they're much smaller. There's a reasonable chance, I didn't see how in detail, but a reasonable chance that here you have something which could preserve quantum coherence up to the level where the new physics would come in. So the non-computational behavior, at least there's a chance. And so Stuart came over to Oxford and we had a long discussion, and yes, this sounded like a really promising idea.
And the transition from the microtubules, where you have maintaining the quantum mechanical effects, to the information being passed through the synapse and the electrical activity, doesn't the latter destroy the former?
Well, the view I had it then, it may not be the view we would have now exactly, but it was just that the strength of the synapses would be controlled by the cytoskeleton, particularly the microtubules, and the microtubules they'd be in some kind of global coherence, which would be what we think of when we're consciously willing something.
When you say global, do you mean between different neurons, or?
Yes, many neurons. You see, there wouldn't be enough of the movement. You see, if you have a quantum, the scheme that needs to modify quantum mechanics in my view, and I think there are good reasons for this, the modification comes when there is sufficient mass displacement. So you have a Schrodinger's cat which is alive and dead. The mass displacement between a dead cat and a live cat is way, way more than you need.
Right.
So that just a tiny mass displacement on classical point of view, but from a quantum point of view, it would be a big mass displacement. That is where you would begin to see the new physics coming in. So it would, the reasons for this come from thinking about general relativity and quantum mechanics and how their principles relate to each other, but let's not go into that now. But this scale wouldn't be sufficient for a single microtubule. It would have to be many microtubules within many neurons acting in concert in a certain way. And so the conscious perception or the conscious willing or whatever it is that comes in at that level would have to involve many, many neurons.
But is it not, has to be expressed in the neuronal impulse as opposed to some other way?
Yes, yes. But this would be how the synapses, you see the strengths of synapses. I think the views are a little bit different from what I've been hearing in recent things from Anirban Bandyopadhyay's experiments and so on, that maybe even the firing of the neurons are influenced to some degree by microtubules. But the idea that I had then was simply in the synapses, the strengths of them in sort of some global way would all be influenced together so that they become stronger or weaker or whatever it is, and this would therefore influence how the neurons actually influence
and this
behavior.
Global coherence caused by the quantum mechanical effects all working together would bring very large numbers of neurons into a different kind of coherence?
Yes, well, yes. I mean, it would be classical at that stage because the neurons themselves, the firing of the neurons would have to be classical. That's what's way too big and decoherent.
Right. But since you have the expression in a classical way, I'm not sure the value of the quantum mechanical effect in creating that. You could have any other different ways. If you're expressing the ultimate consciousness in neuronal impulses, why does it matter that there is a quantum effect beyond the normal quantum effects we see everywhere?
Well, it has to be coherent. I mean, if it's simply quantum mechanics acting incoherently, then there's no sort of global.
Right.
It has to be coherently. That's why we call it Orch-OR. You see, the OR stands for objective reduction. That's where the quantum state collapses to one alternative or another. And the Orch part, it says it's orchestrated. So you have to have this global control or something. The thing is organized in some global way, so that the different reductions of the state actually do make a big difference to what happens to the way the network of neurons acts. So it has to be the neurons because they influence how we move my hands around, things like that. But that's controlled in detail by the individual strengths in which the synapses have. As I say, it's a little different perhaps now, but that was the view I had then.
Some people would do the reverse and say that you need consciousness somehow in the universe a cappella by itself in order to explain quantum physics.
Yes, well, it was a view expressed by a number of people, most particularly the distinguished physicist Eugene Wigner, who suggested that it was consciousness in a sense which reduces the state. So you see, if you want trouble with Schrodinger's cat is that you have to worry about its consciousness. Let's not worry about that. Yeah. The cat would be a superposition of being dead and alive until somebody else comes along and looks at it. Right. And it's the very act of looking at it, in a sense, which violates the superposition principle and becomes one or the other. Yeah. So the consciousness is what does it. This view is basically the opposite. It's what does consciousness. Right. So it's something out in the world which happens physically anyway, and it is what is the basis of our conscious perceptions. But it's an opposite view.
Yeah. Now, the opposite, this view we're talking about, this opposite view, is a justification by some people that consciousness exists as a fundamental reality of the world, and maybe even more fundamental than the physical world. And it's one of the arguments used to defend this view of the fundamental, irreducible nature of consciousness, that it's needed in quantum mechanics.
Yes. Yes, well, the need is just that the arrow goes the other way. It's needed in a sense because it comes about, on our view, whenever the reduction happens. But you need another theory, which primarily has nothing to do with consciousness.
Right,
I mean, just purely a physical theory, which does actually come from current accepted physics. So there's the quantum mechanics on the one hand, Einstein's general theory of relativity on the other hand. You see there's a clash. And this clash says something new has to happen. And in that new thing, the state of reduction of the state, spontaneously, no mention of consciousness, comes about. Then I say, consciousness itself is a feature of that physics that we need for other reasons.
And the other people would use the need for conscious intervention in quantum mechanics in order to justify this concept that consciousness is the most fundamental thing that exists.
Yes, I suppose it's the sort of thing I always used to worry about this. Suppose you take some planet on some very distant star, there's no conscious being anywhere near, maybe a distant galaxy where there's no consciousness on it. And what happens to the weather on that planet? Where you see little quantum effects will make the weather a great mess and stuff. Nothing like an ordinary weather, you see. And then a satellite comes along and has a peek at it, sending a signal to us. You see, whoop, the weather suddenly changes to be one or the other. That doesn't make any sense.
That doesn't make sense.
So it's really doing it itself. Nothing to do with any organized consciousness or anything.
Well, some people would go way beyond and say there's some consciousness present in the universe, whether it's God or some cosmic consciousness that affects this, and this is a way to induce a belief in that.
Yes.
I suspect you don't subscribe to that.
I don't subscribe to that, but it's not an uncommon view. That's right. Yeah. But as you point out, it's completely the opposite, really. Yeah.